Good evening, friends. Welcome to the third episode of Ferro Talk. So today we have Mr. Owen Waldschlagel from New York, USA, and today's anchor is Engineer Rajendra Pawar.
Hello, good evening.
Good evening.
Good to see you again. This third talk. The third talk is the guest speaker is Mr. Owen Waldschlagel. He is from New York, USA. He is a life member of the International Ferrocement Society as well as the life member of Ferrocement Society of India too. He is himself a designer and a constructor and has built many ferrocement structures. He has formed his own company named Intact Structures and has developed his own ferrocement systems for the construction of the ferrocement work. I think he is having this unique design method and ferrocement systems for the construction. I request Mr. Owen to start his presentation.
Good evening, everyone. Hope you're all fine. I do miss coming over to India and meeting with you. Yeah, the reason I made a presentation was I had a few questions to ask about the possibility of some of the components that I designed to be precast. And then the skin, the normal ferrocement skin, applied to those precast components. Okay, there's a building that I constructed in Mexico, which everyone has seen in the past presentations. There's the frame that I must say, this was done on site in Mexico, and the men that were working with me, when I would leave sometimes, they decided it needed these columns because that's how they build in Mexico, and it does not need it. Okay, that's a table in my yard. Most of my work is done in the design of the way to construct the building from these components, which you'll see they can do multiple. I'm trying to move to the next frame. They can do multiple designs from approximately 6 components. Please move this. I don't know if I'm moving it or you're moving it. I'm not sure. Okay, this is an important design. And the same components make this design. And I have it in my yard. Unfortunately, we can't walk outside and take a look. Anyhow, the idea would be that it goes to where there's major problems, and hopefully there are no major problems in the future, but probably there will be, since there always is, right? And to introduce people to ferrocement construction, which can be taught fairly easily with this system, because it starts with point-to-point construction. In other words, the construction is built into the components. It goes together like a kit. This is more or less an illustration of the building that I built in Mexico, trying to illustrate the idea that in a tough place where people don't have much, with a few directors or supervisors, they could construct good, strong houses that would collect and store water and create a good circumstance in society. There's a whole other set that I set that is specific drawings, schematic drawings of the components. This building, the building you saw in Mexico, has been engineered by a New York engineering firm, PEs. That's very important, in my opinion, because my involvement in New York in construction has been with code enforcement. I have never seen. I believe you men certainly have it in India, but I have never seen a code conforming ferro cement house because I know India is like the epicenter of ferro cement. I got it. If I keep doing this, if the Indian Ferrocement Society wants more, I will produce that engineering report because I know you men are technical men, engineers. And I've noticed something the more I get involved with it. It's micro maxi. In other words, the buildings, same components, you can ratio them in and out and make different dimension buildings out of the same components. Obviously, in construction, you could do that in many ways. These components lend themselves. There's a ratio that I've made, which I will produce in drawings and templates that show easily. You say you want a 30-foot diameter, and I call it the initial hub of hope, the hospital, little hospital. When you get a chance, if you guys could look at the component schematics that I sent, there's another batch. Lele, did you see them? I don't know if I sent them to you this time, but they're on my website of what I call the Asian intact structure. It has a sloping roof. Yeah. Same components, by the way, and it's also in my yard. Okay. There was a building that I inspired that was built at AIT that I believe they made it. I asked them not to have me involved with it because they sheetrocked the inside. You know, they did strange things. And I said, please don't say I said, I'm glad. It looks like intact structure, but they sheetrocked the inside. And I don't know, it doesn't have the air vent. But those components do make an Asian intact structures. And also, I don't know if you remember, because it's not up, the initial hub of hope, the round building for the hospital or the food propagation. It's kind of a community building. It's not a house. Right. That's a community building that had, and I'm very into this, the utilization of the attributes of ferro cement. In other words, ferro cement lends itself to catching a lot of water when it rains. Ferro cement lends itself to holding the water. Ferro cement lends itself to making large planters, like I designed around the initial hub of hope. Ferro cement lends itself, more or less, I've written all this in these papers that I sent. One of the reasons they're round is because to get engineered in America, the strength requirements, there's R values, there's all sorts of insulation requirements, and you needed a cavity wall, which is, the components are doing both things. They're making a cavity wall and they're adding strength. Especially if they're precast, they're very you can calculate their strength because it's predictable, just like the panels are predictable. In terms of saying you want a pitch roof, I certainly agree that you could, as you came up, put the panels on. It would be the same system. You just attach the panels there. So I got it. I understand. It's not really a big difference, but there is one. If you look to the website, and I will send it, Pepe. If you keep looking at these components, you'll see they do what I'm saying. And the important thing, it's very important, they're engineered by a PE in New York. That's a big deal.
Thank you, Owen, for your speak on the intact structure ferro cement systems and the way you are designing it. Let us hear some comments on the other experts. At the beginning, I would like to invite our two members who were already in touch with Mr. Owen about his designs and other things. So, first one, Mr. Milind Kulkarni, please.
He has exploited the property of shape and form to actually design those wonderful structures. But they are more of architectural structures, and that is why the hardcore properties of uh, ferrocement, such as bending, flexure, tension, shear, have not really been come to terms with it. I have seen the calculations done by the professional engineer there, and they are very correct. But uh, my point was that, for example, I might make a presentation sometime later on a box girder bridge, ferrocement box girder bridge. Now that is engineering. That is not architectural or a strength through shape and form. It's a completely different aspect and property of ferrocement. Complete bending, complete flexure, complete shear. So a box girder, ferrocement box girder, 35 millimeters thick with 6 meter spans for a pedestrian walkway. So that is another aspect of ferrocement. But coming back to Owen's work, I congratulate him on exploiting the another great property of ferrocement is strength through shape and form. That is what I would like.
Yeah. Thank you, Milind. Can I invite Mr. Lele, please?
Yes, sir. He has done very good work and in Mexico. But my problem is what I face in India is that our requirement, our people's requirement is we, our general people, I'm talking to general people, they want a conventional structure. They don't bother whether it is ferrocement or whether it is conventional RCC or load bearing structure. So we have to meet their requirement with our technology. We have to fit our technology to meet their requirement in economical way.
I think we can, by the way.
Yeah.
The walls are what they are, and then the panels can go over again, the strength, earthquake strength is important.
Yeah.
Earthquake strength is very important. And I agree, but I think the system that lends itself to any kind of adaptation that you're speaking about, especially if you make a hybrid with paneled roof segment.
Yeah.
But I think there's also a utilitarian advantage, say, to what I'm calling the oasis, or the initial hub of hope, the round building. Communities could grow food, go inside, prepare food, and make it much easier to feed a large amount of people in a small area that's isolated, say. And they'd have an earthquake-proof building that would have longevity. So anyway, yeah.
See, there are the advantages and disadvantages of both the designs. Like as Mr. Owen is giving stress on to achieve the strength through shapes and forms, and simultaneously, as Mr. Lele is pointing out, that we need here the conventional designs. The people believe in that, and of course, it has to be a good strength to bear the earthquakes also, like a hybrid design. Now, at this stage, I would like to invite the comments from Mr. A.K. Jain, sir.
Actually, to my way of thinking, ferrocement structures in general do not require a foundation. That is my take. I may be wrong, but I have done it for the last 40 years, and no structure has given me a warning that it is not correct. That if your weight of the structure is about 10% of a normal structure, and the load that you are putting on the ground is of the order of 3 ton per square meter, you don't need a foundation. The ground that we walk on, we put that much load and we don't need a foundation ourselves. So I'm of the confirmed view that ferrocement structures do not call for a foundation. I have never done it. Not only one structure, but all the structures which I have made all over the country, whether it is Nashik, whether it is Ujjain, whether it is Bhuj, whether it is various parts of Uttar Pradesh or Uttarakhand, I have never provided a foundation. Never.
But is it the same for the earthquakes also?
Yes, because that is my contention that once my structures are not anchored to the ground, there is no mechanism of transfer of ground motion to the structure.
Okay.
How will the ground motion will be transferred to the structure? If it is separate, it is like a isolator.
Okay.
Your structure is just resting on the ground. It is not anchored to the ground.
So it breaks the path of.
Secondly, whatever little load is transferred, that is by friction, which is maximum of the order of 40%. Because the friction between concrete and soil cannot be more than 0.4. And then the total weight of the structure is very low. So that is another point that my structures, the earthquake forces, the horizontal earthquake forces are so small that we don't have to worry about them at all.
Right. Of course, sir, you have already designed and executed these projects, so there is no doubt about that. But it will be interesting to know more about the design procedures and how the weight is transferred and make the building safe. Now I will invite Mr. Nandakumar Jadhav for his comments. He is also an independent constructor. He is with his own designs and has won many awards for his very nice buildings he has constructed. Over to Nandakumar.
And basically, what Owen or Lele sir said, the straight through shape. There is a main concept of ferrocement, and there is no shape. If we did a flat slab, then I'm always using a ridge there. Last year, I have made 52 feet length and 21 feet width a flat slab for one community hall. And I will share some photographs tomorrow morning on this group. That was a very fantastic slab. This is a flat slab, box type I have made. So I am always doing each and every ferrocement structure which getting a shape, then there is a no ridge. If structure is flat or something different triangular shape, so I am always using a ridge there.
Okay. Okay. There are many variety of methods of designing depending upon the spans available, the loading structure, the requirements and aesthetic views and whatnot. I will now like to invite Mr. Sakthivel.
But I just want to know the slab which you use, the thickness. What thickness you used for the slab, sir?
In Mexico, where I built it, the ground is extremely stable. It's stone almost. It's a high desert, and we used grade beams of. And there's no freezing floor in Mexico, so we use grade beams with rebar, like reinforced concrete beams. Probably they were in feet, but they were 2 feet deep and 8 inches wide. And it was a grid about spaced 10 foot apart. And on that, we made a rebar cage for the slab. But we filled it in, we compacted it even with the grade beams, very close, with gravel and a rebar grid with 6x6 wire. And we poured a matrix concrete, a reinforced concrete mix, meaning with gravel and sand, like a 1, 2, 3 mix. And it was a very good foundation. We left a space for a 3,000-gallon water tank, which we put into that grade beam circumstance. So there's a 3,000-gallon water tank in the front of that building. But that's the foundation that was under that. And that's an earthquake zone. That's in Oaxaca, Mexico. And they did have tremors, like number 5, I guess, pretty bad earthquakes in the area. And some conventional block houses got damaged near that place, but this house, not a crack. And I was down there maybe 3 years ago, and I searched it for cracks, and I must say, it must be the sand and the cement of Mexico. It must have a volcanic sense to it. In other words, when they make that cement in Mexico, it's Tech, they call it. It's a very good cement, the high quality Portland cement. I think they call it Type 2. I think so. Again, I'm not a cement engineer. I'm mostly structural, physical things. But yeah, it was a slab, a very good slab.
What is the grade of concrete you used?
We don't have 1, 2, 3, 4, 5, 6. There's 6 grades, the way we talk about it. And it was grade 1 is what they use for foundations. Grade 2 is water tanks. It's more with it's more where it's going to get wet. We use grade 2 because it seems to trowel much better on the actual building. And we use river sand. We got the sand down at the river. But that area is volcanic. And I may say the word wrong. I think it's called halzonic earth. There's some earths from around the volcano. The sand is much better to mix the cement with.
Was it sloped roofing, something like that? Yes, sir.
Yeah, it dropped 40 inches. That's where we put the water tank. When any ferro cement apart with all that mesh. In fact, there's a ballistic test from Ferro 6, I think, or 8, and I have it, that shows if you do a cavity wall like that and you fill that with dirt and you do 2 walls of ferro cement, you could shoot a bullet through it and it stops, hits the dirt, hits the cement on the other side, and it's pretty useless.
Did you make any tests? Ballistic, did you make any impact tests on your building?
Not at all. I had it engineered. In other words, after I built it, I had it engineered as built. I did conference with Professor Fernandez and Professor Naman when I was building it. In other words, I told them what I was doing. Alonso had built, you may have seen it.
And was there any leakage? Was there any leakage in your roof?
I was there, and they lived there. That was done, by the way, that was done around 2008. It's been there a long time. And they coated the roof as they coat all roofs in Mexico with some kind of roof coating. I don't know the name of it, but it worked. It wasn't uncoated. It was coated by the conventional roof coating in Mexico. And it didn't leak. The water tank holds. It was a good mix, I must say. It was a very good mix. It didn't leak. And the gutters work very well. In fact, they had to build another cistern. They collected so much water when they got the raining season. They made another tank, and they drip irrigate a beautiful farm on a barren hill from the excess water that they have now. And believe me, in Mexico, there's no water, but it rains.
I have one question to Mr. Owen, sir. In your speech, you have mentioned about the use of ferro skin on the precast units. Can you throw more light on this aspect, where you have used and in what way?
Yeah, the idea would be mostly so that you could prove to a building department how strong the building was. Because if you just depend on a ferro cement building that's troweled and only the skin, it's very hard to calculate that skin. If you have frames, which are the components that I talk about, which are in the schematics, if you have those frames and they're precast, they can monitor the cement mix, the dimensions, the porosity. They can say it's a precast component. And you install those components first, and you leave inserts in them where you can slide the rebar through to take the skin wire. Now, the skin isn't really, it's doing a different type of strength. So you can structurally say these components are this strong, they do this. The skin is just augmenting, adding to the strength, which AIT, Dr. Naveed Anwar, did a finite element analysis of what I'm speaking about. And he also, beyond the engineering work that was done in Axis Design Group Engineering, and they have met, by the way. Amir Islam, who is the engineer in Axis Design, knows Naveed Anwar from Pakistan. And after they both knew me, coincidentally, Amir ended up down at AIT and they conferenced over this. And they both agree that what I'm saying to you, that the components should be calculated. You should be able to calculate the strength of those components. Then you can tell the building department of governments, this is how strong this building is. And then you augment it, just like sheathing on a house.
Yeah.
The sheathing, that tightens up the building. So there's a great advantage of getting it through, to say, the International Standards Organization. That's why you would do that. If you have that, much better than, say, a patent. Say the Indian Ferrocement Society got it through the ISO. You'd have a building system that you could send around the world.
Yes, thank you, Mr. Owen. We have 4 more speakers, and time is running short. So let us move towards Mr. Mohammad Sadeque.
Only thing I want to add, as Milind Kulkarni said, one actually has taken the benefit and advantage of the shape and geometry. That is perfectly all right, and that is one of the beauty of the ferrocement. That is also very correct, because in Bangladesh also I am facing some problem that when I want to take the benefit of the shape and geometry, then initially people a little bit disagree because it's some sort of their culture, yeah. So that is another issue. But one thing I want is most important. This technology or this building is very friendly for cast in situ ferrocement concreting, but I think it's not very friendly for a precast one, because because of this diverse geometric shapes. So we have to think, actually this sort of concept is very nice, very much applicable for maybe a community building or some special type of building. But if we think or the common people for housing, location of the structure, then maybe we have to add the concept of precast, prefabricated ferrocement elements, and maybe we have to motivate our community, our people, little bit to come closer to our geometry. So I think that is the important issue. We, from both sides, we have to compromise, and we will come consensus, and that will be a optimization of I think the ferrocement and community acceptance.
Yes, yes. Perfect. Thank you, Mr. Sadiq. I think he has highlighted a very important point. Uh, I think this is the reason why the ferrocement is not becoming so popular in comparison with RCC. This is one of the factor because people may think that only for the geometrical shapes or some very nicely architectural buildings, for that only the ferrocement technology is useful, not for the conventional ones.
Yeah.
So when we start doing the conventional structures and in comparison with regular RCC and show them the better quality, the different properties, the better advantages, the economies, and then only I think the people will start loving ferrocement more. It's a very valid point. Thank you, Mr. Sadiq again. Now I will invite Dr. Sunil Kute sir, his expert comments.
Yeah, but first of all, let me congratulate Owen for his presentation. It was nice to see him after last conference in Nashik. As rightly was mentioned in the previous discussion, now it's time to take out the ferrocement from the very common and seen conventional example of the boats and all those things. The moment we start with ferrocement, we start with the boats. Nothing wrong in it, that is the history. But now we will have to quote some present and future examples of the ferrocement in the form of housing industry and structural engineering point of view.
Yes.
So that is a very nice application, and that we need to go for the extensive experimentation and research in laboratories on the different characterization and properties, structural properties of the ferrocement. Just before continuing, I would like to ask Mr. Owen that which code you followed for your construction.
Professor Naman told me and Professor Fernandez. I believe Professor Naman was working on a book called the Model Code at that point, and I followed those requirements for rebar and wire mesh. And in terms of the design, the wall cavity, and I really didn't know it at the time. I felt it, how strong it was going to be, because now the engineers have verified that it's very strong. I followed the New York code for insulation, air and light requirements, which is the 6-inch wall cavity and the dimensions of all the windows. Thinking, and I'm still planning on it, although New York's a little shaky. Florida, again, as you know, the pandemic changed the world. You can't float around and do things that easily. Unfortunately, it'll change back. But I followed New York City's code for air and light requirements and insulation requirements, and what they call habitat requirements, like the ceiling heights, room dimensions. And I thought, because I had worked on a ferrocement sailboat, a 50-foot sailboat, and I knew it was very strong because I sailed it in the ocean, and waves are 800 times as dense as air, and it was getting hit by waves, and I said, this thing's really strong. In fact, I said to the guy whose boat it was, I said, you know, this would be a great house. It's very strong. Anyhow, apparently it's very strong, but no, the actual habitat requirements were the New York City codes. In other words, 6-inch insulation, air and light requirements for the amount of dimension of the rooms. And the rest of it became very strong, and it surpassed all the codes of the US anyway, according to the engineers.
For the summary, we had a very excellent discussion on the various design aspects of ferrocement units. Mr. Owen has explained his unique method of designs through intact structures and creating a ferrocement system using it in different ways. He did mention about the ferro skin for the precast units using the model codes and many other aspects. Of course, his stress was achieving the strength through geometrical shapes, and while uh, adding to that, Mr. Lele and Mr. Kulkarni also mentioned to have more the conventional designs and build the pyramid structures as an engineering structure rather than only an architectural structure. So with this, of course, there is not a comparison between as per the requirements and as per the design procedures. We can adopt any one of these. But out of this discussion, I think everybody is now interested in knowing the different aspects of the design procedures. So for that, I think we would start another series in our this Ferro Talk, not from the next Ferro Talk itself, but maybe after a few weeks later, after the first round of the initial talks, taking individual structure, a unique structure designed by a constructor, and giving the presentation only on that one structure, right from its planning, designing, construction, testing, and its cost economics, maintenance, everything. And we will discuss over that. So the design, the structures built by using the different ways of the designs, everybody will come to know and they can share their views with each other. And I think this will enrich our knowledge on the ferrocement technology. So with this, I thank you all the participants for contributing their own experiences and having taking part in a nice discussion as of today.
Thank you very much, sir. Thank you.
Thank you very much. Thank you.
Good night.
Thank you for watching this third episode of Ferro Talk. Please do watch our fourth episode also. Please don't forget to visit our website ferrocementindia.com. Please write to us on indiaferrocement@gmail.com. Thank you very much.